Now we study properties of ethanol. Now what is ethanol? Ethanol, the common name is alcohol. It is liquid at room temperature and it is a good solvent. That's why we use it in medicines. You must notice on the back of the medicine pack, alcohol is there in syrup or anything. So, and it mixes with water easily in all proportions. So it is a good solvent, soluble in water. So that was it. So it was commonly known as alcohol, good solvent, therefore medicines, in medicines, liquid at room temperature, and mixes with soluble in water. Now first we will start with reactions with Na, that is sodium. So when ethanol reacts with sodium, the result is CH3, CO, Na. It is sodium ethoxide. It is sodium ethoxide. Sodium ethoxide plus, and right here H2. So this is reaction with Na. Now reactions with unsaturated hydrocarbon. Unsaturated, I am writing in short, you have to write in full. Unsaturated hydrocarbon. Now this, when ethanol C2H5OH reacts at 443 K concentrated H2SO4 sulfuric acid. Now the resultant will be CH2 plus H2O. CH2 double bond CH2. What it is? It is ethene. Now we will talk about ethanol. So in ethanol, it is mainly an industrial solvent. Ethanol is mainly an industrial solvent. On the consumption of ethanol, that is alcohol, what happens is the person experiences drowsiness. He loses control over himself, that is in walking and thinking. So it is basically he has no sense of what is happening around him. So in medicines also ethanol is there in small proportions. Moreover, methanol, unlike methanol is very dangerous to health. It can also cause death. That is, what happens is methanol, when it goes to liver, it turns very dangerous. It causes harm. How? Because when it reaches there, it coagulates the protoplasm. It interacts with cell and coagulates the protoplasm. That is like when we cook the egg. So it coagulates there and it can cause death. So in ethanol also, some portion of methanol is added. In the industrial solvent, some portion of methanol is added so that no one consumes it. And when the material is added, it is called denatured alcohol. That is, it is turned blue, so that we can figure out what it is and what it is not. So this was ethanol and methanol. Now we will talk about properties of ethanoic acid. So properties of ethanoic acid, it is also known as acetic acid. It is known as acetic acid. Moreover, 5 to 8%, 5 to 8% of acetic acid in water is what we commonly known as vinegar. The melting point is 291 K. Moreover, it freezes. It freezes in cold temperature. That's why it is also known as glacial acetic acid. Glacial, you have to write it full. I am writing it in short. Glacial acetic acid. Moreover, as it is carboxylic acid, they are weak. It is weak. So weak. Now we see reactions. Reactions in first is what is known as esterification. Have you heard about it? What is esterification? Esterification is when alcohol reacts with acid, it gives ester. When alcohol this is acid. When alcohol reacts with acid, what will be the result? It will be CH3, COO, CH2, CH3. This is ester plus H2O. So this is ester. Now, when this CH3, COO, C2H5 ester reacts with sodium hydroxide. When it reacts with sodium hydroxide, what happens? CH3COO, CH3COO Na plus CO2 plus H2O. What is it that we got? It is sodium acetate. This is sodium acetate. Now this ester is a very ester compound which we got this. It is used in fragrances. It is used in fragrances. In the DNA backbone also it is there. In pheromones, ester is there. So it is present at every level. Now we will see reactions with base. Now when it reacts with base, what is that we get? We get CH3, COO, Na plus H2O. What is it? It is sodium salts of carboxylic acid. That is sodium acetate. Now reaction with bicarbonates and bicarbonates. So in this, then CH CH3COH, when it reacts with sodium carbonate, right? What is the result? It is CH3CONA plus H2O. CH3CONA plus H2O plus CO2. This is sodium acetate. The sodium acetate. Similarly, when CH3COOH acetic acid reacts with NaHCO3, here if we have to balance, we can write 2 here, 2 here and 2 here. 6, 6 and then 4. CH3COH plus NaHCO3. What will be the result? Is same. CH3COO Na, CH3COO Na, CH3COO Na plus H2O plus CO2. So this is reaction with carbonates and bicarbonates. Now we see soaps and detergents. So in earlier I explained you about how the soaps are formed. That is, I told you this reaction. That is CH3CO. It is ester. And when it reacts with NaOH, that is sodium hydroxide, we get C2H5OH, ethanol plus this is sodium acetate. So this is formation of soap. That is this reaction is known as saponification. That is soaps. Soaps are formed. Soaps are nothing but sodium and potassium salts of long chain carboxylic acids. Now this ester is also used in fragrance. Fragrance is that this ester is used as fragrances. Now soaps and detergents. So what I do is I show you an activity. This is the activity. This is an oil droplet. How this works, I'll tell you. This is an oil droplet which I have drawn at center. Now this is Na plus ion. Now when we remove dirt, this Na plus ion, it is hydro. This is known as hydrophilic and this one is known as we have drawn this is hydrophilic, and this one, the end, that is this one is hydrophobic. Now it is understood by the name. You know the meaning of phobia. What is phobia? डर लगना. So ये पानी से डरता है, इसीलिए ये पानी से दूर है, और ये जो हाइड्रोफिलिक एंड है वो पानी से इंटरैक्ट करेगा. This is hydrophilic and this is hydrophobic. Now the structure is of micelle, which I will explain you here. So what happens in effect of soap and cleaning? So here dirt is there. This is water surface and here dirt is there. Now what happens? These are the soap molecules. I have drawn soap molecules. This one is the hydrophilic and this one is hydrophobic. That is, one is away from water, that is interacts with dirt, and other comes in contact with water. So see, here it is stationary and doesn't react. They are coming to attack it. Now this is the dirt, the pink part is the dirt, this is the water, and these are the soap molecules. Now what they do is they pull the dirt out. See, they are pulling the dirt out. They are pulling dirt out step by step here, and this is the final step. They have pulled the dirt out and made a colloidal solution. Micelle is nothing but a colloid. गट्ठे जैसा एकदम. There it is colloidal solution. So it is so thick that it doesn't allow the light to pass through it. That's why the solution which we get from soap is very cloudy. झाग वाला होता है. इसीलिए. So see here, in the final step, water is here, dirt is here, the oil molecule which I explained you earlier. Dirt is here and the soap molecules are here. They have pulled the dirt out of the water or cloth. So this is the effect of soap in cleaning.